The single most important bee in the colony is the queen. She is a female like all the rest of the workers. When she was an embryo, she was no different than all the workers. She is then fed a special diet starting at about as a one-day-old larva. And so when a larva is fed that special diet called royal jelly, it will then grow into a queen. That one individual then lays, and all the eggs produces all the new bees. The main reason we're producing queens here at WSU and going to great lengths at this breeding effort is because of the urgent need for stronger queens, queens with better genetics to combat or to counteract these colony losses that the U.S. beekeepers are experiencing.
Every day, WSU researchers are taking on big challenges like colony loss. Queen bee production is one of the tools that entomologists like Dr. Hopkins use in order to improve bee genetics on a large scale. In fact, the technique used in WSU's research facilities mimics a hive's natural queen rearing process in many ways. With only a few key changes, beekeepers can turn a hive into a queen-making factory.
So what happened was in the 1880s, a guy named Doolittle actually, in a dream, it came to him that the queen lays eggs in a dry cell, and then the workers make a new queen. So Doolittle came up with this idea of grafting. You pick up and move a very young larva that just hatched into these little wax cups, and you can put many of them, say 20, 30, 60, on little frames, and you put those in a colony with no queen. So they have no queen. All they want to do is raise a new queen. And now you've given them the means to do this. The way that queens are made nowadays, aside from the fact that we know how to use forklifts and everything, it's really the same as 1888. We're interested in the long-term sustainable solution for bees that are well adapted for our area here in the Northwest and for disease resistance being achieved through breeding. For about the past 15 years, we've been involved in breeding, and so one of the basic principles of breeding is you have to control the genetics of the stock you're interested in. So we initially started with stock from all over the United States, from all the commercial queen producers that we could buy stock from, and then we've been selecting for a number of traits.
Because we are the ones transferring the larva, we get to select where those larvae come from. So we can assess the mother colony, the queen that's producing all those eggs. We can assess the production value of that colony, the aggressiveness or the behavior of that colony. So we can select for bees that are not likely to sting you. We can select colonies that are more hygienic, that remove diseased larvae rapidly before it spreads. You can select for colonies that are more resistant to varroa mites, for example. A lot of people don't think about the male side of things too, so we either selectively choose males and use artificial insemination to breed those queens, or in our case we have a isolated breeding yard, and so that when those queens fly out, the only males they can mate with come from the colonies that we've selected. And then because we like those genetics, we just take the larva from that queen that we like best. So we can take those one-day-old larvae and transfer those into these queenless boxes, and then get a lot of queens from the ones that we like, and then breed, and select and carry on those lines.
Queen bees are the cornerstone of apian society. With a little help from WSU's dedicated team of scientists, these fascinating creatures are poised for success in the Northwest and beyond for generations to come.